Now let's take a look at the subsequent parts, which is of a different kind of progression. Still on 1st January 2001, this person put $100 into the account, and on the first day of each subsequent month, he put another $100. So every month, the first day, he puts $100. And it's mentioned that the interest rate was 0.5% per month. So they explain that on the last day of each month, the account increased by 0.5%. So that's the interest, alright? So in part 2, you're asked to use the formula for sum of the GP. So straight away they tell you it's GP. Otherwise, you should know, right? Because at the end of each month, there is a interest rate of 0.5%, right? They want you to use sum of GP to find an expression for account on the last day of the nth month. And then second part 10 tells you to then hence find in which month the account first became greater than 5,000. So step by step, let's do the first one. So to do this kind of question, do recall, you have learned about this. We typically will try to organize our information into the table form so that we can identify if there's any pattern that we can see. My suggestion is not to use a formula straight away because there is $100 that's added in for each month. So it's not so straightforward that, oh, this is my common ratio and then we can use formula. Alright. So with that, start our first month, and this start our first month is 1 January 2001. Just wanted to keep that in mind, okay? At the start of the month, you put $100. At the end of the month, you have 100. Not just 100, right? You also have the amount after the interest. Now, my suggestion is don't write like that. Now, 0.5% is 0.005 times 100. Now, by writing like this is very lengthy, so instead of saying the principal amount plus the interest, might as well you calculate the overall percentage. So, although here the interest is 0.5%, overall percentage will be 100.5%, right? That's the overall, because original is 100%, then you got 0.5%. So as a result, then I'll get 1.005, which is converted to decimal, times 100. So that's what I'll get at the end of the first month. How about at the end of the second month? To do that, I must find what is the amount at the start of the second month. Amount at the start of second month should have whatever that is left from the first month. Then remember, you always add $100 at the start of each month. Then from there, I take this 1.005 with the interest times the start of the first month. Now your job is to see a pattern, so the idea here is not to expand and then find a value, okay? So group the like terms together, so to speak. This is what I have. Okay, so notice I try to write in terms of a way that I can see a pattern. What about at the start of the third month? So I'm just copying whatever that I have here. Okay, and then don't forget I need to add $100, right? Okay, and then I will plus 100. And with that, at the end of the second month, remember it's 1.005 times the entire thing, right? Times the entire thing I have at the start. Okay, and then here it goes. And then I'll try to write out the pattern. Can you see any pattern already? How many do write, right? You write until you can observe a pattern so that you can tell me what happens at the end. Okay, so at the start of the nth month, then I can say that, oh, this is 1.005 to the power of. Now notice that when it's 1, there's no, right? When it's 2, then this is power 1. When it's 3, power 2. And then the power just keeps decreasing. So you should know that this is power n minus 1. And then the power keeps dropping by 1 unit, so it's 10. Okay, and then all the way until 100. So it always ends with 100, right? Then what about at the start, at the end, right, of the month? Then if you realize when it's 3, this is 3, and then 2, and then go to 1. So as a result, when it's n, then I'll have n. That's 100. and plus 1.005 and minus 1 times 100, and then plus all the way, and the last one is not 100 anymore. Based on the pattern that we have, is 1.005 times 100. And then the question wants an expression for the amount at the end of the nth month. So it means this is the one that I want to try to find the sum. So with that, I'm going to rewrite it, therefore, write it out properly, amount at the end of nth month is equals to, and I can try to group things up, so I can factorize 100, but if you don't want to, it's fine. And then 1.05 to the power n plus 1.005 to the power n minus 1, all the way to 1.005. Now this is actually very difficult for us to observe, or rather to come up with a formula for GP directly. What I'll do is I will try to rewrite the order. So instead of A plus B plus C plus D, I write D plus C plus B plus A. And you realize that, hey, now the power increases. And I can then say that, hey, this is like R equals to 1.005, common ratio, right? And since I know that, then immediately I can use sum of a GP formula now, where A, 1 minus R to the power of, now how many terms are there from 1 to n? Then there are n terms. Okay, and then what you can do is to punch in the calculator, you can put this into your calculator because all these are numbers. So you can simplify it. And then what I have is then 2 negative, right? 2, 0, 1, 0, 0. You can leave your answer like this, or I will get rid of the negative sign by multiplying in. So then this is what I have. Okay, so this is the amount. You want to put dollar sign, you can, but if you don't want to, it's fine. Okay, so that's your answer for part 2. First part of part 2. Right? Then there's a hence part. Hence find in which one this account is greater than 5,000. So essentially, the question just wants you to take this amount and then say that it is more than 5,000. I mean, you can solve from here. There's algebraic way, or there's also the table way if you want to. So go ahead and repeat similar step as part 1. So if you do the table, I'm just going to present the workings on the side. Then you have n. Okay, now generate the table yourself. You should be able to observe for these few values. Okay, and then do write out the corresponding value. If you are stuck here, don't know what to enter the calculator, please let me know so I can help, okay? First, become greater, so we want the smallest n. So therefore, I will say the least n is equals to 45. The question wants the date, so we can go about counting the date. 45, right? Remember, the idea here is 1 January 2001 is that considered the first month, right? So 1 December 2001 is considered 12. So 45, maybe I can do up to 36, right? And 36, then it will be 1 December 2003, right? Because 2002, just now we know is 24, right? So 1 December, so it's 37, then it's 1 January 2004. So I know quite clearly I need to have 9 months, right? It definitely will be 2004. Then you can count very carefully, and it's 45. That means from here to here there are a total of 9 months, right? And if you start from 1 January, so that means you end in 1 September 2004. So this is how I suggest you can count, and therefore you can say that the date is 1 September 2004, and that's part 2.